Okay, we're on section 9.3, and this is going to be an interesting one. We're going to talk about and expose some ideas that you may not have seen before. So 9.3, here's our objective. I can understand, use, and prove, and I'd like you to underline the word prove right here. Prove angle relationships and measures. Okay, now prove is an interesting word. We want to have some pretty convincing arguments for this. Now, if you take a look at these notes, they're fairly long, but they take up a lot of space because we got a bunch of geometric diagrams in them and stuff like that. So don't worry too much. This warm-up, it says find the distance and the midpoint. So we want to find both of those between these points right here. So remember, the distance formula is this. Distance is the square root of, big square root of, and it's x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So on this one, it's going to be a big square root, and then I'm going to end up, let's see, x2 minus x1, so negative 1 minus 3, put parentheses around that and square that, plus, and then y2 minus y1, so that's going to be a 4 minus a minus 5 quantity squared. So this is a negative 4 quantity squared, and this is a, let's see, that's a 9 quantity squared. So this is going to be, let's see, 16 plus 81. So I think I end up with radical 97. And the nice thing about radical 97 is I don't think that factors at all. So we'd either leave it like that or maybe come up with a decimal approximation for it. And then if we want to find the midpoint formula is different. Remember, this one we're literally just averaging the coordinates. So this is going to be x1 plus x2 over 2. And y1 plus y2 over 2. So on this one, let's see what we get here. This is going to be 3 plus negative 1 over 2 and negative 5 plus 4 over 2. So this is going to be, let's see, that's going to be a minus 1. So that's going to be a 2 over 2. And that's going to be a negative 1 over 2. So we get 1 comma negative 1/2. And there we go. So we've got the distance is radical 97, and the midpoint would be 1 comma negative 1/2. Okay, some more vocabulary now. A transversal, so transversal is the new vocab. It's a line that passes through two lines in the same plane at two different points. So in the diagram below, we've got a transversal. Transversal P intersects lines Q and R. So here's the transversal. So this is the transversal, and trans means to cross something. So transversal, okay, it crosses lines Q and R. And we're mostly interested when the lines that it crosses, that the transversal crosses and intersects two parallel lines. We get some really cool results if it's crossing parallel lines. So if the two of these are parallel, then we're in great shape. And we normally indicate parallel by putting little arrows on these. Now, it didn't say that on this, even though it looks like it. So I'm going to go ahead and erase those, and let's talk about the vocabulary that we use to indicate each one of these angles. Okay, and the first vocabulary word is corresponding angles. So corresponding angles are in the same position in their respective intersections. So if you can kind of imagine this like a street intersection, and corresponding angles, they're in the same place in the intersection. So if we came to this intersection running along here and looked over to our left, I suppose, okay, this would be 1. Same thing would happen here. So 1 and 5 correspond. If we were looking across the intersection, 2 and 6 correspond. So that means 3 and 7 correspond. And of course, the last ones that would correspond are the two of these. So that would be angle 4 would correspond to angle 8. And we could kind of go through and we could match these up. I could do some highlighting right here. Each one of these with the same color on them, those are all corresponding, okay? So corresponding just means they're in the same place in the intersection. Now, alternate interior angles are this. They're on the inside. That's why we call them interior. They're on the inside of the two parallel lines, but on opposite, so let's write the word opposite here, opposite sides of the transversal. So I'm going to go ahead and erase these guys, and let's talk about alternate interior angles. So alternate interior angles, they have to be on the inside. So 1 and 2 and 8 and 7, they're on the outside. They're on the exterior, so it can't be those. So they're on the inside, but they're on opposite sides of the transversal. So 4 and 6 would be alternate interior, and 3 and 5 would be alternate interior. So 3 and 5 and 4 and 6. Now, if you know that, then we could also use the phrase alternate exteriors. So if we were talking alternate exterior, they would have to be on the outside of the parallel lines, and they'd have to be on opposite sides. So angle 1 and angle 7 would be alternate exterior, and angle 2 and angle 8 would be alternate exterior. So I'm going to say angle 1 and angle 7, those are alternate exterior, and angle 2 and angle 8, alternate exterior. Okay? All right, so we're going to come down here and we're going to take a look at a couple of theorems that are related to these guys right here. So vertical angle theorem. If two angles are vertical angles, then they are congruent. Now, you're probably familiar with this from other classes. We've probably talked about that in this class. But vertical angles, they are always congruent. Vertical angles are always congruent. Okay? Corresponding angle theorem. So those corresponding angles that we were talking about up above, they're in the same place in the intersection, like 1 and 5 and 2 and 6 and so forth. So if two parallel lines are cut by a transversal, then each pair of corresponding angles are, you guessed it, they are congruent. Okay? They're the same size and shape. Alternate interior angle theorem. If two parallel lines are cut by a, remember we cut across them, so that's our transversal. Okay, then each pair of alternate interior angles is congruent. So if I've got angle 4 and angle 6, those are congruent, and angle 3 and angle 5 are congruent. And then there is an alternate exterior angle theorem, and the alternate exterior angle theorem says probably what you would expect it to say. If two parallel lines are cut by a transversal, then each pair of alternate exterior angles are congruent. So if I were to match these up, and I can't get my, there we go, get that to erase there. What that means is alternate exteriors are congruent. So angle 2 and angle 8 would be congruent, and angle 1 and angle 7 would be congruent. Okay? Now, what could we say about same side interior angles and same side exterior? So let's think about that for just a minute while I erase these guys right here. So I'm getting rid of the alternate exterior, and we're talking same side interior and same side exterior. So let's look at a couple of same side interior angles first. So same side interior, if we were to look at the two of these, 4 and 5 are same side interior. Well, if you look at those, this is a small angle and this is a big angle. Well, it turns out those actually add up to 180 degrees. And we're going to talk about why that happens in just a few minutes. And same side exterior, so if we look at 1 and 8, again, there's that big angle right there, and there's a small one, similar in size to 4 and 5 and stuff like that. So that means they also equal 180 degrees. Okay, so they are supplementary. Okay, in other words, they equal 180 degrees. So i.e. equal 180 degrees when we add them together. Okay, so let's come down here and take a look at this diagram. So it says identify all pairs of vertical corresponding alternate interior and alternate exterior. And then part B, we're going to be given some information about this. So vertical angles. Vertical angles would be angle 1 and angle 4, because those are across from each other. Angle 2 and angle 3, because those are across from each other. Angle 5 and angle 8. And the last set would be angle 6 and angle 7. Okay. Corresponding angles, let's take a look at those. Remember, those are in the same place in the intersection. Angle 1 and angle 5, those would correspond to each other. So angle 1 and angle 1 and angle 5, angle 2 and angle 6, angle 2 and angle 6, angle 3 and 7 would correspond, angle 3 and angle 7, and let's see, the last one would be angle 4 and angle 8. Now, when we start talking alternate interior and alternate exterior, it gets a little bit easier because there aren't as many pairs. If we're on the inside, there's only 4 to choose from. So alternate interior would be angle 3 and the one across and on the other intersection. So this is going to be angle 6. And then if we've got 3 and 6 taken care of here, the other one would be angle 4 and angle 5. Those are alternate interior. And alternate exterior, 2 and, let's do it first, 1 and 8. So angle 1 and angle 8. And then the other one, of course, would be angle 2 and angle 7. Okay. Now, here's what's interesting about this. You'll notice that this has lines on there. We've got this little arrow here, and what that does is it indicates that these two lines are parallel. So this cuts across those parallel lines. Our transversal cuts across there. So if we're given just one of those angles, then we can figure out a whole bunch of information about it. So I'm going to go and mark over here. Angle 1 is 72 degrees. So I'm going to go ahead and mark that as 72. Well, we know that corresponding angles are congruent, so I can mark this as 72. We also know that vertical angles are congruent, so I can mark that as 72. But there's a vertical angle down here, so that is 72 degrees. Now, in order to figure out the other ones, we've got to remember that if we've got a straight line on one side of a straight line, that equals 180 degrees. So if this whole thing equals 180 degrees from here to here, I'm going to do 180, and I'm going to subtract 72, and I get 108. Okay, so that angle right there, angle 2 equals 108. I could do the same subtraction right here because that makes a straight line, and I could make the same argument over here. But then we could just say, well, wait a minute. These are vertical angles, so this is going to be 108. And then we can come down in here and say, well, let's see. Corresponding angles are vertical, so this is 108, and angle 7 is also 108. Okay, so given just one piece of information with this transversal and two parallel lines, we've got a whole bunch of good information there and can figure out the rest of them. So let's flip the page over and see what we've got there. All right, little bit of a mess on example 2, but I think we can figure this out. Things we want to notice is we've got some marks right here indicating that these two lines right here are parallel. These other ones are not, and you can tell because, pardon me, they intersect in angle 1. And it says, find the measure of the remaining angles. So in order to do that, I've got the diagram here, so I'm just going to make this a little bit bigger so we can write a little bit easier on this. And we're going to come through and mark what we know. So what we know is that angle 5 is 110 degrees, so 110 degrees right here. Angle 17 is 95 degrees, so 95 degrees right here. And then what this really amounts to is the last problem that we did, just done twice. So these are the parallel lines. So I'm going to come through here and say, hey, vertical angles are congruent, so that's 110. These are next to each other and they make a straight line. They're supplementary. They're a linear pair, so that's got to be 70 degrees. Whoops, let me change that right there. 70 degrees, because 110 and 70 make 180. So that's got to be 70 degrees. And then if I follow this over here, these are the two parallel lines. There's the transversal that cuts across it. So this intersection has to look exactly the same as that intersection. So the corresponding angles, 110, 110, and 70 here and 70 here. So that one piece of information about angle 5 got us all 8 of these angles, and then we can do the same thing on this one. So if this is 95, that's got to be 95. And then these have to be a linear pair. They've got to be supplementary between 16 and 17. So 180 minus 95, that's going to end up being 85 degrees. So that's got to be 85 degrees. This intersection would look exactly the same. So 95, 85, 85, don't mess that up, 95, and there we go. Now there's one more that's missing, and that's right here. And in order to figure that out, we've got to rely on what's called the triangle sum theorem. Hopefully you remember that. Inside a triangle, there's always 180 degrees. So these angles right here plus angle 1 would have to equal 180 degrees. So angle 1 plus 70 plus 95 has to equal 180 degrees. So if we put the two of those together, this would be angle 1 plus, I think we got 165 here is 180 degrees. Or, you know, most people just end up saying, look, I'm going to add the two of these together and then I'm just going to subtract from 180 and figure out what I've got left. So 15 degrees right there. And again, it might look bigger than 15 degrees, but we're not worried about the way things look. We go off the information when we're doing geometry. So we don't have to write down all of these, but it does say write down several of them. So let's go through and find these. Let's see, angle 1, we got 15 degrees for angle 1. Angle 6, let's find that. That's 70 degrees. Angle 7's right here. That's 110. Angle 9, let's find 9. That is 95 degrees, even with my crappy handwriting. Angle 10 is over here. That's 85. Angle 11, that's 95. Angle 13, that's up here. That's 110. and angle 16 over here, so that's going to be 85. And we could have asked all of these. Again, there's 17 angles, but we probably don't need to take the time to do that. Okay, now, here's where it gets a little bit interesting, and this is going to be a bit of a brain-stretching activity because you probably haven't seen too many of these before. We've done a few arguments of why a statement would be true and kind of proved something in air quotes. But here's what a proof is. A proof is kind of a step-by-step argument containing logical reasons that justify and establish that a statement is true. That's really what we're after. We want true equations. We want true statements. We want to know that what we're saying is absolute fact. Now, there are lots of different ways to make proofs. We can do diagrams. We can make paragraph arguments. We can just make a statement to another statement and so forth. One of the more common things that you'll see, especially in geometry, is we'll do what's called a two-column proof. And that's what we're going to do here. We're going to do some two-column proofs. Now, you'll notice that it's aptly named. We've got a column right here and another column right here. So we've got two columns, and the first column has some statements in it. And the second column are the reasons why those statements are true, or the justifications, okay? So I'm going to write justification, okay? Justifications. So here's what we want to do. Now, when we're proving something at this level, we're usually proving something that's a pretty easy idea. In fact, it's an idea that most of the time we're going to go, well, no, duh, we already know that. I mean, we can tell that just by looking at it. That's really not the point. What we want to do is we want to change part of our brain that could make an argument to somebody and say, hey, this statement is true, and I can show you step by step by step by step why it's true so that nobody can really argue against that. So this is not the only way to prove that vertical angles are congruent, but that's what we want to do. So this is what we want to prove true. We want to make sure that this is actually true. So we're going to be given a couple of things. So if we're going to prove something about vertical angles, it says angle ABC and angle EBD, they're vertical angles. And we want to prove that they're congruent. So this is sometimes called the hypothesis of the statement or the theorem, and this is called the conclusion. So if we're given the fact that they're vertical, we want to prove that we can conclude that these two angles, that these vertical angles are congruent. So the first thing I'm going to do is I'm going to highlight this right here. So we are given that angle ABC, so ABC, that's this angle right here, and angle EBD, those are vertical angles. So EBD, so that's this one right here. Those are vertical angles, all right? And we want to prove that they're actually congruent. So we're given that they're vertical, and we want to prove that they're congruent. So here's what we're going to do. We're going to take a look at this, and we're going to take each one of these statements step by step, and we're going to provide some justification for these. So the fact that these two angles are vertical, well, they gave that to us. So the first step in one of these type of proofs is they just gave this to us. So we just write given. The next thing is that ABC is supplementary to CBD. So let's identify these angles. ABC, that's this angle right here, is supplementary to CBD. So when we add these together, that makes them supplementary. Yeah, that's a linear pair, okay? So they're definitely supplementary. So I'm just going to write linear pair right here. That's how we know that. And then the other statement here is that EBD is supplementary to CBD. So EBD, this one right here, is supplementary to CBD, the same one over here. So notice how these overlap. They're both using angle CBD, this little sliver of an angle right here, to supplement this big angle to make the straight line, okay, to make it so that it's supplementary. So then they say that the measure of angle ABC plus the measure of angle CBD is equal to 180. So the measure of this small angle right here plus this other little piece that we augmented to that we added to that equals 180. Well, when they're linear pairs and they're supplementary, that means they equal 180. So I'm going to write down that is the definition of supplementary. Remember, we said before that supplementary meant they add up to 180 degrees. So here are two angles that we know are supplementary. So we automatically know, or can assume from that, I guess you could say, that they equal 180 degrees. So if these two angles are supplementary, then we add them together, they equal 180. And if these two angles are supplementary, we add them together and they equal 180. That's the definition of supplementary. They equal 180 degrees. Now, what we're going to do right here is something a little bit clever. We're going to take this equation right here, and let me highlight it. We're going to take that equation, and we're going to change it a little bit just by doing this. Angle ABC still is on this left side, but now you'll notice what's happened is angle CBD has moved over to the other side, and we did that by subtracting angle CBD from both sides. So that's actually the subtraction property of equality, and you might remember that from previous years. So subtraction property of equality. And that's basically saying you can subtract the same thing from both sides of an equation and you still get a true equation. And then you'll notice that we've done exactly the same thing on the next one. We've got angle EBD. We moved the CBD to the other side, so this is 180 minus angle CBD. Now, this next one, there are a couple different ways that you could talk about this. Here's what I'm going to here's the way I would say this. So, angle ABC is equal to 180 minus angle CBD. Angle EBD is equal to 180 minus CBD. So you'll notice that these two things are the same. So wherever I see a 180 minus angle CBD, I can put that in its place. So I'm just going to substitute this in right there, and I get angle ABC over here equals angle EBD right there. So I would say this is the substitution property. Substitution property. Okay, and you can just say substitution if you want to. There is a little theorem in math that says something like this, and you could also use this one if you wanted to. It's called the transitive property of equality. So if A equals B and B equals C, then we automatically know that A equals C. It's kind of like cutting out the middleman right here and just saying, well, A equals C. And if you take a look at this, that's actually what we did. Angle ABC equals this, and this equals angle EBD. So we can cut out the middleman and just say, hey, well, these two things have to equal each other. Now, this step happened to take this proof happened to take 4 or 5 steps. We could probably add a few to these. We've proved that the measurements are the same, and then we can just say that they're congruent to each other. But this is totally okay. We're just going to go with this for right now because we're just kind of introducing how this works. So I'm going to slide down here. Again, we've got the transitive property. That's about the same as the property of substitution. So let's take a look at this one. We want to prove that corresponding angles are congruent. So we need to start with the fact that they're corresponding, and we need to prove that they're congruent. So line Q is parallel to line R. So these two are parallel, so I better mark that over here. And angle 1 and angle 5 are corresponding. And there's no doubt about that because that's just by definition what they are. They're in the same place in the intersection. And here's what we want to prove. We want to prove that angle 1 is congruent to angle 5. And like we said before, we're always going to start off with something that's given. So they gave us all this information. So in our little statements that are step by step, where we can walk somebody through baby steps from here to here to here, so everybody can agree, yep, I can see what's going on there. So here's our first statement, and our reason is given. Angle 4 is supplementary to angle 1. Well, let's take a look at that. So it's saying that those are supplementary, and yeah, they are because they make a line. So the reason for that is we're just going to say that they are a linear pair. And linear pair, by definition, they would equal 180 degrees. Okay, so let's take a look at the next statement. The next statement is angle 5 and angle 4 are supplementary. So that means if you add the two of those together, you get 180 degrees. Well, let's see here. These are on the inside of parallel lines, and they're on the same side. So the reason for that is these are same side interior angles. So the reason they're supplementary is because they're same side interior angles. Now, we've got angle 1 is supplementary to angle 4. So that means the two of those add up to 180 degrees. We've got angle 4 and 5 are supplementary, so they add up to 180 degrees. So you might remember this. Well, that's the definition of what supplementary is. So we're just going to say definition of supplementary. Supplementary means they add up to 180 degrees. So we can write an equation saying those two angles add up to 180 degrees. Now let's take a look at what happens here and see if we can spot this. This is angle 1 equals 180 minus angle 4. Angle 1 equals 180 minus, well, they just moved the angle 4 to the other side. and angle 5 equals 180 minus angle 4. So again, they moved the angle to the other side. So this is, like we did up above, subtraction property of equality. Now, you might be sitting there thinking, oh, I don't remember all those properties that we went over last year. If you need to dig some of that out, I believe that's in Unit 1 in Secondary 1. You can pull some of those things out. I don't think you need to worry too much. I think we're going to cover most of the properties that you would need. We're not going to go over the exponential property of equality or anything strange like that. And then let's take a look at this last one here. So this is what we've got. It says angle 1 is congruent to angle 5. Now, what we wanted to show was, we wanted to show that these two angles were congruent because they're corresponding angles. So angle 1 should be congruent to angle 5 because it's corresponding. And what we've done here is we've said, hey, angle 1 is equal to this. Angle 5 is equal to that same thing. So we can cut out the middleman or do substitution. So you can say substitution, or you could say the transitive property. Transitive. Okay, and that's that whole idea. If A equals B and B equals C, then A has to equal C. We just kind of cut out the middleman there. Okay, all right, let's take a look at the other side here and see what we've got. Okay, we need to prove that alternate interior angles are congruent. So let's take a good close look at this. We have to start with the fact that they're alternate interior angles, and we have to prove that the two of those are congruent. So we're given the fact that those two are parallel. Okay, so that's going to be a given. And then angle 5 is congruent to angle 7. Angle 5 is congruent to angle 7. Now notice that they've been pretty nice here. They filled the stuff in for us. We just have to provide the reasons. So angle 5 and angle 7. Well, those are vertical angles. Okay, that's why they're congruent. Angle 3 is congruent to angle 7. Angle 3 is congruent to angle 7. Well, we already proved that vertical angles are congruent, so we can use that one. And angle 3 and angle 7, those are congruent because those are corresponding angles. So we just proved both of these steps 2 and 3, corresponding angles. Okay? If they're corresponding angles, they're congruent. So we can definitely use those again. And then let's see if we can come up with this one right here. Let's see. We know that angle 5 is congruent to angle 7, and we know angle 3 is congruent to angle 7. So there's our middleman or our transitive angle. That's what we can substitute for and stuff like that. So we end up with this. You can again say, and I'll put transitive first on this one. So transitive property of equality. We could also say substitution. Okay. Now, we could go through a similar pattern, a similar argument to show that angle 4 is congruent to angle 6. So 4 and 6, those are both alternate interior. All we have to do is show that one pair of alternate interior angles is congruent, and we can assume that all of them are after that. We kind of proved the idea, so we can use that idea from now on. Okay, so we're on to example 5, and you'll notice that this has two parts to it. And you'll notice that the columns are empty here. So we need to construct these on our own. We'll need to fill in all the information. So let's put our heads together and see if we can figure this out. It says use the figure to prove the following. Now, it says that given that L is parallel to M, so L and M, I'm going to mark those so we've got that given part right there. And if it's given to us, we do have to start with that because otherwise somebody wouldn't be able to look at this and make any assumptions about it. So we're going to say that line L is parallel to line M, and that's given is the reason for that. And then we want to prove that angle 2 is congruent to angle 7. Angle 2 is congruent to angle 7. All right, so let's take a look here. What we've got is we've got alternate exterior angles. So we basically want to prove something that we already know or we've been told. So let's start off with this. Angle 2 and angle 3 are congruent. So angle 2 and angle 3 are congruent. So let's put that the two of those equal each other. Those are congruent, okay? Angle 2 is congruent to angle 3. And the reason we know that is those are vertical angles. So vertical angles. And what we need now is we need some sort of bridge between angle 2 and angle 7 so that we can prove this statement. Well, 3 and 7, those are in the same spot. So angle 3 is congruent to angle 7. And the reason we know that is those are corresponding. So corresponding angles, okay? And then, you can kind of see what's going on here. This happens a lot once we get used to this. Angle 2 is congruent to angle 3. Angle 3 is congruent to angle 7. So we automatically know that angle 2 is congruent to angle 7. We cut out the middleman here. You can call this the transitive property, transitive prop, or substitution. And I will work on my penmanship at some point, but probably not right now. So transitive property or substitution. Okay, let's slide down and take a look at the very last one and see what we can come up with here. I'm hoping you're getting the sense that even though proofs look kind of scary and they're kind of, it seems like, oh my gosh, do we really have to do this? You really are working out and stretching a different part of your brain than you do with a lot of other thinking that we do in math. So I really like these. Well, like is maybe an overstatement. These are okay, especially if you enjoy thinking and stretching your brain. So we're given this. So line L is parallel to line M. So we're going to want to mark that on this. And we want to show that angle 3 plus angle 5 equals 180 degrees. So angle 3 plus angle 5 equals 180 degrees. So that means that the two of these together, if we add them up, well, wait a minute, 180, that means they've got to be supplementary. So we maybe want to keep in mind. So I'm just going to put a dot right here and a dot right here, and I'm just going to put a plus between the two of those and maybe a 180 off to the side. So here's our goal. So here's the first thing we want to do. We want to state what we've been given so everybody knows what the ground rules are. So line L is parallel to line M, and that's a given. They gave that to us. We don't have to prove that or make any other statement about it. And we somehow want to make some statements that involve angle 3 and angle 5. So here's what we're going to start with. If we notice, angle 3 and angle 1, they make a linear pair. They make 180 degrees right there. So we're going to say angle 1 plus angle 3 equals 180 degrees. Now, if we were to get technical, we'd put the measure of angle 1 plus the measure of angle 3 equals 180 degrees and all that sort of stuff. We're not worried about too many details like that right now, but that's because they make a linear pair, okay? And linear pairs make a line, line's 180 degrees, okay? Linear pair. Okay, the next thing we want to do is we kind of want to match this up and somehow have a bridge. We've got angle 3 mentioned so far. Somewhere we've got to have angle 5 mentioned here. Well, if you'll notice, angle 5 and angle 1 are corresponding. Okay, so we could actually make a statement about angle 1 and angle 5. We could say that angle 1 is equal or congruent to angle 5. And the reason for that is they're corresponding. Okay, now you can probably see what's coming here. What we wanted to prove is we wanted to prove that the measure of angle 3 plus the measure of angle 5 equals 180 degrees. So I am going to come back here and I'm going to put some m's in there. And I kind of notice, well, I'll come back and make a big deal of this in just a second. So if angle 1 is congruent to angle 5, I can put 5 in its place. So I'm going to write this down. The measure of angle 3 plus the measure of angle 5 is equal to 180 degrees. That's what we wanted to prove, and I've got it in the right order. So what I did here is I basically just substituted angle 5 in here, and we can do that because the two of those are equal. And then I just put the angle 3 first in the equation rather than putting angle 5 where angle 1 was. Now, so the reason we can do that is this one is definitely substitution. Okay, we literally just replaced that. There wasn't any transitive property or anything. Substitution. Okay. Now, I want to come back here and say, hey, we could get really nitty-gritty and technical about this, and there are people that do that. I'm going to add one extra line to this. So, angle 1 is congruent to angle 5, and we know that because they're corresponding angles. If we take a look at the other side, we actually proved this up here. We proved that they're congruent, okay? But remember what congruent means. Congruent means that the angles measure the same. So if we say they're congruent, I could put a little arrow in here and say, kind of like therefore, the measure of angle 1 is equal to the measure of angle 5. Now, some people make a huge deal about this, that, hey, congruent is not the same as equal and stuff like that, and that is technically true. Congruent means the shapes are the exact same size, or the figures are exact same size and shape, and equal means the numbers that measure those are equal. So if we're going to come up with an equation, we probably ought to have numbers in here, and we probably ought to have an extra line in here. But for the purposes of what we're doing, okay with this, just kind of introducing the idea. Okay, now that took a while to go through. We went through lots of proofs, went through a lot of vocabulary and everything. The assignment is not that long. You can take the ideas that we've talked about here, and I think you can see examples of each one of those and then apply those and just kind of get thinking in that direction. All right, good luck with the assignment.